Capital K means we're in global coordinates, right? Global coordinates, but we're still in local form. Why? Because when we look at the nodes that are involved, we only have two nodes, and our whole system is actually made up of 3 nodes. So until you have all 3 nodes showing up, you're dealing with the local form. So that's why this is called the local form. And we want to go from the local form to the global form. So that's what we're going to do now. So we want to have something that looks like this, where we have all the nodes showing up and the elements of X, or elements of I and J on this one. So we basically want this 6x4 matrix to be created. So we're going to go from a 4x4 to a 6x4. So let's see if we can do that here. So here's our our transformation matrix. So you've seen that before. So again, a lot of similar wording here, so be very careful with that. But you can see this back in the linear algebra review, how we have this and how this works on the setup. But because element 3, we're looking at element 3 here specifically, we only have nodes 1 and nodes 3. So we're not going to have anything in this row because there is no node 2 in element 3. All right, so that's why there's zeros here. We just have ones here and here because we're going to include IX and IY for the global displacement for node 1 the X direction and node 1 the Y direction, and similarly with node 3. All right. If you wanted to, and it went the other direction, if we set it up so that our triangle like this, if we had 1 and 3, and we defined this was I and this was J, then we just have to reposition and we'd say, here's J, and node 1 is J, so 1, 1, and node 3 is node I, and we use 1, 1 here. Right? This is what we actually did, so we're going to stick with this, but this is what you could do if you went the other direction, right, to make sure you loaded them properly. So make sure you get comfortable with that as you do some examples with that. All right, kind of lost. Hopefully you can see through that. So that the angle will be different in the K matrix, all right, in the global form matrix, global coordinate local form, the local form, local to the element. But when you get it into the global form, all right, amongst the whole system, it'll be the same. All right, so we'll see that here in a bit. So let's do that. All right, so we're trying to go from, so these were global coordinates, local form. We're going to go to global coordinates, global form. All right, so we're going to put in our transformation matrix. So this is our 6x4 matrix we're going to put in for element 1. And probably the easiest thing to do is just put this in, insert this way. So we get a, let's say 6x4. So we get that. And element 1 is made up of node I. Maybe let's go, yep, so we'll see right here. So we got node I down here in the bottom left corner, and node J is node 2 over here on the right. So I is 1, J is 2. All right. So if I is 1, then we can put a 1, 0, 0, 0. And I'm just using the right arrow key to move here. 0, 1, 0, 0. All right. So that's, now we have I set up as 1. Now J is 2. So J starts in this one right here. So that's a 1. And we got 0, 0, 0, 0, 1. All right, so that's element 1. I'm going to come back here and backfill in the zeros that I missed. All right, so that's our transformation matrix. And now if we want to transform our local form stiffness matrix from up above that we just did, we're going to type in our trans 1, so the matrix we just created over here, times K sub 1. So it's our K sub 1 is our global coordinate local form stiffness matrix from above. Multiply that times trans 1, the transform of that. So I'm going to use Control Shift T to make sure I get the transformed version of that. Now if I hit equals here, again, it's kilograms per second. Let me change that over to pound for inches. All right. So you can see here, if we go up, so we got 1, 1, or 1, negative 1, negative 1, 1, up here in the upper left-hand corner. 1, negative 1, negative 1, 1. Right. So that's what we have here in the upper left-hand corner. So we have, if we go across here, this is node 1 in the x, node 1 in the y, node 2 in the x, node 2 in the y, node 3 in the x, node 3 in the y. So for element 1, we just have 1 and 2, so that's why it's just showing right there. All right, let's keep doing that for element 2. Come down here. All right, we need the same thing. Let me close this actually so we can see things a bit better here. We're going to do the same thing. We're going to do a 6 by 4. Oop, undo. Click there first. There we go. There we go. So 6 by 4. All right, so element 2, go back to the slide here. Element 2 is made up of nodes 2 and 3. And 2 is node I, and 3 is node J. So let's start right down here. So node I is 2, so we'll go 1, 0, 0, 0, 0, 1, 0, 0. And node J, this kind of set of columns, is related with node 3. So we got 1, 0, 0, 0, 1. And backfill, and zeros. And we're going to do the same setup here. So we got trans 2 times our k sub 2. So again, our global coordinate local form of our stiffness matrix times trans 2 transformation of that matrix equals, and yeah, it goes off the page. So we can go to the different view here. So here's draft view versus page view. Page view is what basically you'd see when you print it off. So we go to draft view, it kind of extends it. And so we can delete off that pound force inches, enter. And go back to page view, see if it's a little bit, yeah, it still shows. I like page view, it's a little bit cleaner as opposed to having draft extend on beyond that, but you can do what you like. All right, so that's element 2, we look good there. And let's go down here to element 3. So we'll expand this. Again, we'll put in our 6 by 4 matrix there. And now element 3 is made up of node 1 is node I, essentially, and node 3 is node J. So 1, I, 3, J. So I is 1, and 3 is J. So we got 1, 0, 0, 1. And the backfill. Looks good. All right. Let's transform this guy. So we get trans 3 times the global coordinate local form of the stiffness matrix times trans 3, transforming that, equals, all right, it takes me back to the giraffe version here automatically. We'll change the units. Get back to page view again, like being a little bit more clean here. All right, so then we get the different positions there. All right, so let's look what happened here. All right, we created these global matrices. All right, we created this, 1, 2, and 3. That's what we just created. So we're going to add these together to create the global coordinate, global form of the stiffness matrix. All right, so it ends up being a 6 by 6 because we have 3 nodes and there's two components at each node we need to be interested in. All right. So element 1 shows up here because it's made up of nodes 1 and 2. Element 2 shows up here because it's made up of nodes 2 and 3 in the bottom right versus the top left. And note here what I try to do too is you can see the where it overlaps, you see the colors. So blue and red gives you purple in the middle. So that's where we have some adding and subtracting going on. Now, what about element 3? Element 3 is made up of nodes 1 and node 3. So for node 1, we're going to see it here as well as here because of being involved in node 1. And for node 3, see it here and here. So again, it's basically element 3 is yellow. So where yellow overlaps blue is green, and where yellow overlaps red, we get orange. And then we get yellow in the two corners. All right, so that's where they all come together when you get added into this global matrix, global stiffness matrix. All right, so let's go do that. Really easy. So come down here and get our global stiffness matrix. So our Kg value here is just Kg sub 1 plus Kg sub 2 plus Kg sub 3. All right, I'm not going to hit equals on this line because it'd be too go off the page here. So we'll just do it on this line here and update the units here. Just click right on past them. Delete these guys. Come on, get out of there. All right, pound force per inch. All right, so we can see all those values. And actually right here we can catch these values here from the local form, or sorry, global form for just element 3. And then we see that these terms are added. I can't really see them here added in here, but these terms are not added in anywhere. They're right here in those spots, and these 4 guys are in these 4 spots right here. All right, so we can see those come through. All right, so there's a global stiffness matrix.